Hi, welcome back. So we're in chapter 4, inferential analysis. In this chapter, we're going to cover a few sections. First, a quick introduction on the meaning of inferential analysis, then estimating parameters, and finally, hypothesis testing. Let's go ahead and review the first outline of introduction. Now, let me take you to a visual presentation to understand the concept of inferential analysis. Now, essentially, in the descriptive model, we were looking at three toolkits we have utilized: univariate analysis, and then the bivariate analysis, finally the multivariate analysis. In the univariate analysis, we were trying to understand distribution, the central tendency, as well as the dispersion of each vector. And then in the bivariate analysis, we were looking at two vectors at the same time. What is actually the relationship? We use the tool of variance or covariance analysis. Then the multivariate is just expansion of these two together. What is the actual output of this? You will come up with a summary. Now, once this summary is done, you could say, well, I have a descriptive model. And descriptive model, essentially, it's a kind of scientific answer to the research question. There is a population. And what you have done, you have drawn this n number of subjects. And then you have done this set of analysis, and then you give this summary. Now, the question is, what are those summaries? Those summaries come from those tools. For example, in the distribution, we looked at proportion, the central tendency. We looked at the variance, standard deviation, right? In the bivariate, we've looked at the covariance, the correlation, the range. Now, the point is, those, imagine them as points, right? And those are the actual summary that help me to make an answer to my research question. Now, those points were captured or calculated based on this n. But once again, this n is just a sample. It is here of this big population that has actually n number of subjects. So the first question is, how can you be sure that this summary you have yielded are actually good representative or actual image of the population behavior? If you want to see the image, these points here, proportion, mean, variance, are actually also happens to be exist in the big population. There is a proportion, there is a real mean, there is a variance, there is a standard deviation. So what is the difference actually? You are telling me these points I captured here from this n samples are actual representative here. To make sure this is really true, the point you captured are actually very close to the real population characteristic in here. Inferential analysis helped me to do that. And to do that, inferential analysis utilized the power of two important actually tools: point estimate and then hypothesis testing. Basically, the point estimate is trying to give you a guideline. Those points, they are really quite a good representative of the real population characteristics or points. And in the hypothesis testing, it's related to the summary. Test whether what you have reached out to can be accepted or maybe can be rejected, in other words. So this is actually what we shall be looking at, the third pillar of analysis, and that is inferential. An important differentiation between population and the sample that you draw. If it happens this number is the real population number, I mean the entire population, we give the sample of letter n. If it is a sample, we give it little n. Say if it is the mean, we give it as a mu if it's belong to the population, or we give it x bar if it's belong to the sample. If it is variance, we give it a sigma square if we're talking about population, or we give it the s square if we are talking about sample. If it is, of course, a standard deviation, just a sigma and the s. And finally, maybe in some books also about the proportion aspect, that we give it p here in a population, or a p hat if it is a sample. These are the symbolic presentation. Most likely, actually, in most of the cases in real life, you are dealing with the sample. Now, in general, also, academically speaking, the population, those are called population parameters. And now when we talk about sample, these are called statistics. Now, I hope this quick introduction about the actual understanding of the job of inferential is quite clear to you. Let's go ahead and review the first tool that inferential utilizes, and that is the study of estimating parameters. I will see you then.